So it's called the hydraulic pump, or it can be called the gear pump. If we are going to classify it according to the material we pump it with, it's going to be a hydraulic pump. If I get to classify it by the way it's working, we call it the gears pump. Because the concept is very simple. We are going to have two gears moving together. We have the main shaft and we have the follower shaft. How it's work is very simple. We put them in the gear case, the main gear case. Okay, so it will look like that. I'm showing that on the screen. Okay, so we have two gears here. This one is going to be connected to a motor. It can be an electrical, it can be mechanical, and that's actually what we have in the case of the, the trash compressor, the collector for the trash when they're compressing the trash and make, yeah. So this will rotate. That's the main. This is the follower. Will start to rotate at the same time. From the other side, we're going to have two inlets. Actually, one of them is inlet, one of them is going to be outlet, the ports. This one is going to be the inlet port, and this one is the outlet port. Larger because it's going to have the suction effect, so it's going to take suck the oil or the fluid at higher rate. And then we need to pressurize it to increase the pressure and increase the velocity, so it should go from the smaller port. How this happening? As the pump is rotating like that, we're going to have below here a negative pressure area, because we try to take the fluid up to here. So we are going to have suction effect. It's going to have a negative pressure in this area, so the oil will run through the pump. Pressurize at this point, at the top here, as it's going to move. And this will give only one way to the oil to leave, which is going to be through the outlet port. We're going to look inside the pump case. It's all. You can see obviously that what we have is going to be. These are the holders for the shaft. But from here, the big hole, this is the liquid coming from the inlet port, and leaving from the top one, which is going to be the outlet port. Small one, pressurize the fluid so it's going to go at the higher velocity, because what we need is the pressure more than the flow rate. How this part was made. If you inspect the surface here, you can see it's quite rough. Sand casting. It's quite heavy. Sand casting, the mold will look like that from the outside. We're going to have the cores, and actually you can see, you can check the cores later when you come to here, is we have rough surface from inlet, from inside. So we had two cores here, one core here, and the pattern. We make the mold, we fill it with the liquid metal, solidify. We're going to have the main part ready. Machine the face, drilling, tapping, okay, boring, honing to make the surface good surface finishing. From the other side, we're going to have the boring, threading, done. This part is finished. The same process is exactly, yep.
Do they do the threading from the inside?
For this one, the other you can do it with the manually, we can do that. But this one actually was cut on the milling machine. You can cut on the milling machine.
From the inside you can do it?
From the inside, yeah. So we have a cutting tool, it's look like that. Start to rotate and going down at the same time, so it's going to cut the helical shape, so it's going to look like a thread. That's for the main body. For this part, exactly the same process. Casting, we're going to have core in the middle here, core on this side. Then when we finish the thing, face milling, slot cutting, drilling. This will be through holes, unthreaded. The same thing here. We're going to have the boring. We're going to have the milling operation, and the part is done. That's the main body. We had this part we call the thruster plate. Thruster plate. We're going to put the gears. We're going to have some space because we cannot cut it exactly to these dimensions. Also, when this part is going to rotate, I don't want to damage the main body because this costs to make. Instead of that, I'm going to have a protective part which is going to be made of aluminium. This will simply going to be weird before the stainless steel shaft is going to be weird because this one has stronger material than the aluminium. So I put the thrust plate as a protective for both the main body and the shaft. Actually, we should put one down and one at the top, but I'm going to show you the top one only. Okay, so it will sit here. Okay, so what's happening is going to keep the pressure. At the same time, it's going to protect both the gear, shaft, and the body of the pump. How this part was made is made of aluminium, and the process we made it of. Actually,
oh, it's pretty light.
Yeah, it's aluminium. Yeah. How we made it? Die casting. Yeah. It's very simple shape, so we can cut the mold by using the milling operation. You don't have to talk about how the mold was made, but we are going to inject it with the aluminium multiple times, open the mold, get the part, trim the channel, the channels for the feeding, and you're going to have the part ready. We can make many of those at the same time. You may able to talk about the alternative material for this one. For that one, it must be made of the cast iron because this part is heavy, it's going to have very high pressure from inside. I saw video do the machining for it using the aluminium, but of course the one with the aluminium is going to have a different shape because we cannot make it with all these details by doing the machining process. The aluminium one is going to take less pressure. This one is much stronger. Okay, so we made the thrust plates by die casting. This one is sand casting. And now how to make the shaft. The shaft, you cannot cast it because this one is going to have the torsion force, high pressure on the gears. If it's going to be cast, it's going to be quite brittle. We want it to be stronger. So we get the bar and start to machine it until we're going to have this shape. So machine is going to be on the lathe machine, of course. We have two stages, so we have to do the part, side A and then side B.
Oh, so that was all one middle part?
All one bar.
And then they...
Yeah, and then we start to cut it here. First on the lathe machine, then we put on the milling machine to do the process of the gear cuts, as I showed you last lecture. So what we're going to put is on the indexing device. It's going to hold it like that. Then we're going to have the milling cutter passing by, pass, then rotate, pass, rotate, until we're going to have the gear cuts generated. For the supplying, we can do it either on the milling machine, and we saw that once again on the video during the lecture last week, or we can do it by the protruding process. The protruding process is the device which have a multiple level teeth. When we're going to push it here, we're going to have the final cut. So the supplying and the gear can be cut on the milling machine, but the bar itself is going to be cut on the turning machine. After we finish with the cutting operation, we need to do the surface finishing. And this is we're going to talk about this one next week. This is what we call the super finishing process, because if you touch the part, it's very fine surface finishing to avoid any friction with the part itself. Now, once again, to protect the part, we're not going to make the contact directly between the shaft and the part and the body. What we have here is, you can see that we have a ring before the push. We put this one inside, and it's going to play two roles. The first one is to protect the main body. It's made of copper. Usually it's going to be made of copper, and it's going to be coated with Teflon material. Why we call it with Teflon? How?
The fusion thing.
Now, this pump is pumping hydraulic, which is a lubricant material. But when you're going to start for a while and we're going to start again, is going to have a problem which called the dry starting. The dry starting, that means the part will stop for a while and then start to work, rotate very fast, dry, and this will increase the erosion of the part due to the lack of the lubricant. So if I get to coat it with Teflon, the Teflon will absorb and retain some of the hydraulic. So when I get to start next time, it's going to be wet. So no dry startup in this case. Okay, so we talked about these two pushes. We said about the cutting of this one. Now, the last thing which is required once again in the case of the in the marking criteria is the testing operation. How we test the pump. Actually, I have video for that. I can show you how to test the video, how to test the thing, but I can tell you about it now. Now, how we can test the dimension of this part? Using a CMM machine. It can touch all the surfaces, check the dimension. Yep, and it's going to tell you if this part is fully spherical, circular shape, the T dimension are correct, because this is very important thing. We should have very high tolerances between the gears. Otherwise, we're going to jam the teeth of the gears and not going to rotate. But you can see now they are rotating very freely, very nice, because they are good to a very good dimensioning. How to check the main body? How you can check if the plastic bag can take a certain amount of pressure? What are you supposed to do? In general.
Just put everything in and check if it works.
What will be the best thing you are going to check that the pressure is going to be distributed equally inside the bag? Fill it with water, right? So the same thing can be done here. If I would like to check if this gasket part is very good, I just close it. Of course, I should have a gasket. Close this side, lock, well, actually, it's going to lock the both ports. I can put that with the plugs. And then I start to pressurize the main body with high pressure of water. And I'm going to leave it for a while. If it's going to damage, that means it's a bad casting. If it's going to take the pressure, for example, for 30 minutes, that means this one can take the pressure in the operation process. Why water? Because it's the safest material I can use. If it's going to go all around the place, it will dry after a few minutes.
How about wouldn't there be any leakage with the pressure of the water coming out?
There will be some leakage, but yeah. So that's what we have to check. Usually when you pressurize something, something like when you check your tire, you're going to have a gauge. It's going to tell you if the pressure is going down or not. So we're going to add the water with the gauge, leave it for 30 minutes, and should keep the same pressure inside. If yes, pass. That's the easiest way to do the quality control for most of the pumps. Actually, it's not only this pump.
Yeah.
Okay. What else we have? You have to talk about the off-shelf item. For example, we don't have to make the bolts. We can purchase them directly. The machine we are going to use are going to be, well, we need a foundry process. We need to have a milling machine, boring machine, the drilling tapping machine, and turning machine. Of course, milling, cutting for the gears as well. We have multiple processes to cut the gears, but this one definitely was made on milling operation. The material, stainless steel, cast iron. Different rate of the cast iron can be possible. Usually the aluminum one is not going to be strong enough for this model. For lighter pressure, maybe it's going to be aluminum. We have different models here. This is the other one, but usually I prefer to work on the purple one because I know most of the dimensions. Anyway, we'll see. Yeah. One of the things you are going to be asked to do is find what was the original length of the startup material to cut these parts. Now, do you have any idea how to find out what was the weight of the actual road we start to do the cutting with on? What will be the easiest way to know that?
Find the maximum length and then maximum diameter and then just find the volume.
Yep, that can be a possible thing. And how to know the mass? Because we are going to be asked in the assignment paper to find what is the loss in mass during the machining operation. Now, mechanical engineer, among any other engineering, maybe just a civil engineering sharing the same thing, we working on the how to make the things easier. But not electronic engineers, we have to stuck with the theory. We are mechanical and civil engineers, just try to solve the problem as easy as possible. How to find the volume of this spot?
The maximum length, maximum width is a cylindrical volume method.
That's for the original one, but what about this one now?
Displacement.
You can use the water displacement. Is that going to be reasonable to do it now? Getting water, getting this cold cylinder, put the thing in, check the increase in the level.
I don't have a machine that does that.
Now I will give you a very easy method. We have a scale there in the back. Again, to put this gear on it, and the weight is going to be 1,557 grams. I did that many times before. Okay, I know the mass. This one is steel, stainless steel. The density of the steel is 7,300 kilogram per cubic meter. So if I'm going to divide the mass I have by the density of the steel, I will know what the volume of the spot directly by calculation. How many cubic meter volume we have for this spot. Now we come for the cylinder. I will check the maximum dimension here. I think that the height for this one is something about 57 millimeter. That means that the original diameter of the cylinder I start to working on, according to this standard, is going to be 60 millimeters. Then I removed 1.5 millimeter from one side, and this removed the total 3 millimeter from both sides. And for the height, I think it's 202 millimeters. Of course, I'm going to do the facing operation. I'm going to cut it off from a part, maybe. So 202, maybe I'm going to use 220. Okay, or you can say 205, 210, and you're going to minimize the cutting. To do this one on the turning machine, you have two options. The first one is use the normal turning machine. You hold the part from one side, it was 60 millimeter diameter, and start to cut the 3 levels. And then you take it off, turn it, hold it from this side, and start to machine this part facing, then the turning operation. Then take it to the milling operation. That's why we have these two ends, because it was sitting on the indexing machine, and start to turn it, synchronizing the movement with the cutter on the milling machine. Super finishing, as we said, we can do the heat treatment for this part or that part if you want. This part of the process we have. What else? Yeah, I'm going to show, I have an Excel sheet calculator to calculate the machining time of this part by using 3 different cutting tools. And I'm going to show you how to use it in the tutorial later. I think that's it. We don't have to talk further about the major project because we're going to have a session about it later. Okay, so once again, we talked about the offshore material like this seal, and we have the ring O-ring inside. So these two parts, offshore item, you don't have to make them. Done. Now let's go back working on your project.
The testing of it later.
You can test it if it's good.
How we test that?
I told you, just pressurize it with water.
I mean, like you said, you had a video.
Oh yeah, I got no. This will be sent to you later. Actually, I have also this slide, but I'm going to show you through the video. Okay. I think that's going to be wasting our time to do it now. Yeah, I just wanted to. Now we understand the processes. You can repeat the video. I'm going to repeat the video again, and have some photo for the parts. Show you the videos for the processes and.